Welcome. I like to ride my mountain bike in about a 7-mile circuit near my house. It includes uphill and downhill, and by the time I'm finished, my muscles tell me I've done work. From a physics perspective, mechanical work can be expressed as a force times a distance. That begs the question, what force? That's true. You must specify what force you're considering and what object the force is acting on. If we consider the force of gravity acting on me and my bicycle, when I go uphill, since I am moving in a vertical direction opposite to the direction of gravity, gravity does negative work on me and my bicycle. When I go downhill, I am moving vertically in the same direction as gravity, and gravity does positive work on me and my bicycle. If I end at the same place I began, so that my net vertical displacement is 0, gravity has done net of 0 work on me and my bicycle. I'm Dr. Courtney. In this problem, we're asked to find how far an airplane is moved when it's towed by a tractor at an airport. The big idea here is that we're going to use the definition of mechanical work and we're going to find the distance a plane is towed by a tractor. And in this case, we're actually given the total amount of work done. And we're given the tension in the cable, or whatever the linkage is, and the angle at which the tension is acting. We'll see how that comes into play in a moment. As we develop this problem, we start with a sketch of what's happening. So I'm not even going to try for an artistic rendition here. We have a plane on the ground being towed from the gate by a tractor, which is smaller. Since the tractor is smaller, the linkage between them is acting at an angle. So we call that angle theta. And since the tractor is pulling the airplane, there's some tension in the linkage, which we call T. So we're actually told in this problem that theta is equal to 20 degrees. We're further given that the tension is 4.5 times 10, 4.2 times 10 to the 5th newtons. And the total work done by the tractor on the airplane is equal to 8.5 megajoules. This is the information and the physical setup of the problem. Our plan is first we'll check our units, and then we will express work done by the tractor on the plane in terms of the other quantities. The tension T, the displacement D, and the angle between them. Then we want to solve this symbolically for the distance traveled, since that's what we're interested in. Then we can substitute our actual numbers and compute D. Then when we report our final answer, we will consider how many significant figures to use. Let's begin. Considering the given values, we have work given in megajoules, which is not an MKS unit. So let's express the work. 8.5 megajoules, mega means times 10 to the 6th, or times a million. So we can express that as 8.5 times 10 to the 6th joules. Now let me also take this opportunity. Joules is a unit of work named after a scientist with the last name Joule. However, it also can be expressed as a joule is the same thing as a Newton times a meter. This will help us with our unit analysis later on. So, as we express work, work is equal to a force times a distance. But we've learned that force and displacement are both vector quantities. So those are vectors, but work is a scalar quantity, meaning it has a value but no particular direction. So we compute work from these vector quantities by taking the dot product. And that can be expressed as the magnitude of the force times the magnitude of the distance times the cosine of the angle between them. So this is where the angle in the linkage between the plane and the tractor comes in. Now we're interested in how far the plane moves. So now we can solve for that distance. And our force, well, just to be clear, let's write this again one more time. The force is the tension in the linkage. So let's write that as T. D is how far the plane is moved by the tractor, and theta is the angle of the linkage between them. So now we can solve for that displacement by dividing through by T cosine theta. So work over T cosine theta is equal to the distance we're interested in. Now we can substitute numbers. The work was 8.5 times 10 to the 6th joules, which I will write as newtons times meters. And the tension was 4.2 times 10 to the 5th newtons, that's a unit of force, times the cosine of 20 degrees. We compute that carefully with our calculator and get that the plane has moved 21.53 meters. Considering significant figures, each of our given values has only 2, so we will report our answer to 2 significant figures as well. 22 meters. How can we decide whether this is a reasonable answer? Well, first of all, let's assess ourselves by starting with our unit analysis. When it came time to substitute specific values into the equation, I included the units. So newtons times meters divided by newtons, our unit of newtons cancels. Cosine of 20 degrees is a unitless number, so we're left with meters for our distance, and that makes sense. That's what we would expect. So our units check out. We probably didn't forget any terms or forget to convert anything. What else? Well, obviously 22 meters probably isn't even the length of the plane, since it's specified as a jumbo jet. So whether this is a reasonable distance or not, we really have to go back to the specific quantities we were given. So in this case, I would suggest go ahead and double check the calculations, because dealing with scientific notation and division, it's easy to make a mistake on a calculator. So double check the calculations, and if you come up with the same answer, then it's likely that you've achieved the correct one.